In this video, I am going to discuss the differences between breadth first search and depth first search. Um, Here, if you see the strategy of the breadth first search is it would visit and explore all the adjacent vertices. In DFS, the strategy is it would visit one vertex and explore. So, it explores the BFS, explores all the neighbor nodes, all the adjacent nodes at current level before moving to the next depth level. When it comes to DFS, it explores as far as possible along each branch before backtracking. That is first difference. The second difference is the BFS uses a queue data structure. The second difference is data structure. Breadth first search uses queue data structure and depth first search uses stack data structure. It is first in first out data structure and this is last in first out data structure. Third difference is the traversal order. The traversal order of each and every vertices. So, this BFS traverses level by level. BFS traverses level by level in a breadth first manner. Whereas a DFS traverses deep into a branch. It traverses deep into a branch in a depth first manner. And the next difference is memory usage. Generally, BFS requires more memory to store the queue data structure and DFS requires less memory as it only needs to store the current path, because we used to pop out every time whenever we perform backtracking, the nodes would be popped out from the stack. So, it requires only less memory as it only needs to store the current path. Next difference is about the complexity. So, the time complexity of BFS is big O of E plus E, also DFS is big O of E plus E only. The next step is applications, the next difference. The applications of BFS already we discussed in the BFS video. One is shortest path algorithms, where the BFS can be applied, shortest path problems, web crawling, puzzle solving, all these are the example applications under BFS. Whereas in DFS, again we discussed a few sample applications in DFS video as well. One is topological sorting, second one is cycle detection, third one is finding strongly connected components in a graph. These are the sample applications of BFS and DFS, and the next difference is about finding a path. This BFS helps to find the shortest path in an unweighted graph. It finds shortest path, BFS finds shortest path in an unweighted graph. When it comes to DFS, it may not find the shortest path, but it depends on the search order. Because it depends on the search order, so it may not find the shortest path. So, it is BFS is guaranteed to find the shortest path in an unweighted graph, but DFS is not guaranteed to find the shortest path. And BFS is suitable for finding shortest path and exploring all possible paths within a certain distance, whereas in DFS, yes, it explores all possible solutions and paths only exhaustively. And the next difference is backtracking. If you check BFS, it doesn't involve backtracking, whereas DFS involves backtracking, because if the node cannot be explored in DFS, we would be performing backtracking to the previous nodes, to the previous level vertex, but DFS doesn't involve backtracking. DFS does not involve backtracking, as it explores all possible paths level by level. Here in DFS, yes, it involves backtracking, as it explores deeply along one branch before exploring other branches. So, these are the differences, possible differences between breadth first search and depth first search. Thank you.